Good morning, students. Welcome to our Bachelor of Education in Senior Primary Mathematics 5. This is BES Mat31, the code of the subject. And I am your tutor, Miss Loide Ampolo, and that is my contact number 081-2009-524, or you can reach me by email loidemetu@gmail.com. But I prefer you just as a WhatsApp for like a picture of your question, and then I'll help you and I'll attend to your question on time. Okay, welcome to Mathematics 5. I wish you all to be hard-working students. And then this presentation will cover very few, only two, but I want you to pay in mind because I feel like you need to know a bit on this part, and then some guidelines that I want you to put in mind when you are preparing for your examination. And remember, this is an examination-based presentation that will cover April, May, August, and November examination. And now for some general information, the total marks for the assignment is 130. The total marks for the examination is also 130. You need to score a minimum of 50% to qualify for the examination, and then 52% to pass your examination. That is roughly 65 over 130 for you to be considered that you have passed this examination. Use the examination pad when you are writing your assignment. I know you have submitted your assignments already, and I hope you wrote them in your examination pad or something just presentable. And then you can also try to type your assignment, but when it comes to drawing graphs, for example, you use a computer if you are 100% comfortable with it. Otherwise, just draw with your hands to avoid losing marks on incomplete work. I have seen this one, and some students lost marks because not all the information that was supposed to be in the graphs were in the graphs. Do the assignments by yourself to familiarize yourself with the module and questioning techniques, and this will help you when you are preparing for the examination. Also number the questions according to the question paper. Skip a line every after each question, and make sure that your final piece is neat and legible, and all the pages are numbered, arranged in order, and securely fastened together. Just to avoid some pages not being there, make sure that your final piece is in good format, and then it's safe also. The introduction. Mathematics is a very complex subject, so we cannot do everything in 1 minute. Please note that I cannot give attention to the whole content, so should you have any question in any topic, you can contact me. This presentation will therefore just cover a few minutes, as I said before, and try to watch previous presentations done on mathematics. It will help you in case there's a topic that you did not understand how to do. You can watch those previous topics that were done already, so that you learn from them as well. This is not an examination scope. And then use the prescribed text study guide or the textbook when you are presenting or preparing for examination, and when you wrote your assignment. So then when you are preparing, have your assignment aside, and any topic that you maybe know that you did not do well, just try by all means to go back to the textbook and make sure that you know that part and every other subtopic under that one. The first chapter is numbers. Numbers is the very first chapter in Mathematics 5, and then it's a very complex chapter, and then you need a very good understanding from the beginning for a smooth learning of other chapters. Mathematics, is intertwined. Okay, and then you are required to know different types of numbers now to answer questions involving them. For example, even numbers, odd numbers. These are type of simple numbers, but you find that some of the students cannot differentiate between even and odd numbers, prime and composite numbers, and which numbers are prime. So then just don't ignore them. They look simple, but make sure that you know them 100%. And then you need to know how to do calculations involving directed numbers, fractions as well, to know how to find the lowest common multiple, highest common factors of up to 3 whole numbers. You must know how to do calculations involving percentage, inverse percentage for instance, for especially, and also interest and everything else under percentage of quantity, making one percentage as a one quantity as a percentage of another one, and so on. Maybe your assignment, if your assignment only looked at percentage in inverse percentage, it doesn't mean that I cannot ask percentage of quantity and others. So then if it's percentage, if you see percentage in your assignment, you have to read everything under percentage, and that is how it is. You must know how to work with money, ratios, rate, proportions, and also calculation involving direct and indirect variations. So then when you revise each topic and each subtopic, you should look at the parts that are also connected to that topic, not just concentrating on that focus on part alone, but you should also look at the branches on that topic. Your examination number 1 requires you to round off your answer to 3 significant figures. If the answer is not exact, you should round off to 3 significant figures. And I'm going to be strict on this as well. If you did not stick to this instruction on your final answer, that's it. If 3 significant figures, you should round it to 3 significant figures. And I want to look at rounding off to significant figures for now. A significant figure is the first non-zero digit. Like in this case, example, 0.098. 0.098, 9 is the first significant. A significant figure is the first non-zero digit. This is 0, the beginning, we won't count it. This one is the beginning, we don't count it. I always tell my learners, like, if I'm having a number like this, how are you going to read this number? Of course, this is just 11. So then 0 at the beginning is meaningless. But if the number is like this, 110, of course this is 100 and 0, and 0 here is countable. 0 at the beginning doesn't really, it's not significant. It doesn't that much affect, in most cases, the value of the number, especially if it's a whole number. Decimals is another thing. Then if we're having now 60,432, so then the first significant figure here is 6 because it's not a 0. So then make sure that you know how to round off to significant figures. I have some examples here. If I say now 318.0 to 3 significant figures, what will be the example, the answer here? The first significant is 3, the second significant is 1, the third one is 8. So the 8 is the third significant. We are rounding off 8. What will be the answer for this? When we are rounding off just have the same method as rounding off to any number. So then this one's going to be, look at the next number on your right. Can 0 round off 8? Not at all. So then this is then going to be 318. So 7 to 3 significant figure, this will be the answer. Now what if I'm having 0.03077 to 3 significant figures? We should know which number you are rounding off as a significant. So then 0 is not the first 0 is not significant. This one is not significant. So then the first significant is 3. The second one is 0. We are rounding off this. 7 is the third significant. So then you round off 7. You look at the round of the next number to your right, which is 7. Can 7 round off 7? Of course, yes, because 7 is more than 5. So then that one will become, normally add 1. That will be 1 more. 7 will become 8. And these other numbers will remain the same. So then that will be 0.0308. 0.0308 to 3 significant. You can see the 3 significant figures that you need. Now another one is, what if I'm given 50,006? Which one is the third significant? We have 5, The first one is 5, 0, 0. So then we are rounding off this number, 0. 0 is the third significant. Can 0 round off 0? No, that means our 0 will not change. And probably this now is going to be 50,000. This one will not change. All other numbers become zeros now. So then into three significant, this is going to be 50,000. I want you to make a difference when you are rounding off decimal numbers and when you are rounding off whole numbers. You will find that sometimes a student will just stop here. This was 50,000. 50,000 cannot just be 500. So then before you move on to the next question, when you are rounding off, make sure that it's also making sense. Then we have 76,035. This is also a whole number. So then it's a whole number. Look at the thousand that are given as well and replace them with 0. 7 is the first, 6 is the second. You are rounding off this 0. Can 3 round off 0? No, that means our 0 will not change. This one will not change, 7. And these other numbers, we cannot ignore them. The answer cannot be 760 because we are given 76,035. So then make sure that these numbers become zeros so that your number will be also having the same value. It cannot be 76,000 and all of a sudden we have only 760. So then make sure that your answer is finally correct. The next one is a decimal, 0.9152 to three significant figures. Which one is the third significant? 0 is you cannot count it. 1, 2, 3, we are rounding off 5. And 5, can 2 round off 5? No. So then 2, that means 5 will not change. It will remain 5. 1 will remain 1, 9 will remain 1, 0 will remain 0. But now here it's not, even if we put 0 here, it won't make any difference. So then decimals, we can ignore these other numbers. But then when it comes to the whole numbers, you may have to make them zeros so that the number can have the same value. If you have any other question, more questions on how to round off significant figures, so then please contact me for that. Another part that I want us to look at a bit is reverse percentage. This is finding the original. This is finding the original quantity or working back to the 100%. Let's look at this example. The number of learners in a school is 24% lower than in the previous year. Find the number of learners in the previous year in the school if the school has 1,216 learners now. That is the question. Reverse percentage. So then you have to look at the number of learners now, and then that will be last year. It said now if the learners now are 1,216, how many were they a year ago? This is the value that you want. But then you are told that the learners are now 24% lower. If they are 24% lower, last year they were 100%. Now they are 24% lower. How many are they now? So then that will be now 100 minus 24. And 100 minus 24 will give us 76%. 76%. Now they are 76%. Now we want this 76%. This 76% represent the number of learners now. Now how many were they last year? So then we can now make our cross multiplication on that. That will be 1,216 times 100 divided by 76. Then we can get our answer on that. So then it's a matter of going back. If it's a plus, an increase, you add here. Then if it's a reduction, a minus, a loss, then you have to do what? You have to subtract. Okay. Then the next question is A fridge worth 3,799 is sold at a 5% profit. That is profit now. Calculate the selling price of the fridge. Okay, we have the cost price and the selling price of the fridge. You are told that the fridge that is the cost price of the fridge. Now the cost price is 3,799. Now you are asked to work out the selling price, but then you are told that it was sold at a 5% profit. Now the selling price is now going to be more than the cost price because there was a 5% profit. The cost price was now 100%. How about the selling price? The selling price is going to be 5% more because the person made a profit. So then that will be 100 plus 5. 100 plus 5, it will be 105%. So then the selling price will be 105%. Then it's a matter of making your cross multiplication. That will be 3799 times 105% divided by 100. Then you get your answer. We have also different methods of doing this, so then you can choose a method that you are comfortable with. Otherwise, when it comes to reverse percentage, please refrain from that old method. In most cases, we just make, like here, you find that a person will just make 5/100 times 3799. Then you get the answer here. Then you add, which is totally wrong. So then it's a reverse percentage. So and then you must know when to add a certain percentage and when to subtract it from an original 100%. Okay, if any question there, then please just contact me so that I can give more examples and explain more in detail. Then we have variations. Variations is also one part that I found that students are quite struggling with. Variations in mathematics is defined as a relationship between two variables that can be expressed by an equation. We know what an equation is. A change in one variable will cause a change in the other. Variation can either be direct or maybe indirect variations. The direct variations expressed by an equation y is equal to kx, where x is an independent variable and y is dependent and k is the constant of proportionality. And indirect variations, they are expressed by an equation y is equal to kx. So then it's a matter of knowing those two formulas. Direct y is equal to kx, and indirect y is equal to k over x, whereby this k it's a constant proportionality. It's a constant. We can either multiply or divide by the same number without changing this. Is constant. It remains the same. The symbol for proportionality is that one. So then let's look at this example. Y is directly proportional to x. If y is equal to 6, when x is equal to 2, find the constant proportionality. You should know which variation you are working with. Is it direct or indirect? And according to this question, it's direct. So then if it's direct, you have to use this formula. Okay, y is directly proportional. So then this is our formula. Y is equal to kx. And then we can substitute. The first question is find the constant proportionality. So then you have to find k. To find k, we substitute. We are given the y and the x value. So then if y is equal to 6, we substitute y with 6. K is the one that we don't know, and then we substitute x with 2. Okay, then we work out. This is 6 is equal to k times 2 is 2k. Then we divide both sides by 2. The same way we solve equations. So then k is equal to 3. Now we will know that our k is equal to 3. Now the second question is find the value of y when x is equal to 9. Now it's a matter of putting in it's just a matter of substituting. When y is equal to kx, that is our formula for direct proportion. And now when k is equal to we are working out y. What is the value of y when x is equal to 9? So then y will be, we know that k is equal to 3, and we know that x is equal to 9. If k is equal to 3, then x is equal to 9. We substitute those two values so that we can get y. Y is equal to 3 times 9, which is 27. And then the next question is find the value of x when y is equal to 30. We know our formula is y is equal to kx. We know that our y now in this case is 30. We substitute y with 30 is equal to k. K is 3. We know our concept proportionality here, and x is the one that is the value that we are working out. So then coming here now, so then that will be 30 is equal to 3x, and then I want x, I can divide both sides by 3. That means x is equal to 10. Now these are not really difficult mathematics. It's just a matter of knowing which the variation we are working with. Read the question, is it direct or indirect? Then the next question, it said it is given that x varies inversely to the square root of y. If it's inverse, then x is equal to k over the square root of y. It will be like that. Because it's an inverse direct proportion, it's k over something. So then the question is now, if x is equal to 3, y is equal to 25. Find an equation connecting x and y. What will be the equation here? For us to find an equation, we must know our constant proportionality. We must know the value of y. Then from there, we now work out the formula that connects x and y. Let's move on. So then, if x is equal to 3, we substitute 3 with x, and then k is constant, y is 25. That will be the square root of 25. So then we move on. That will be, this one is also 1. So then k is equal to 3 times the square root of 25. K is equal to 3 times the square root of 25 is, the square root of 25 is 5, and then we know that k is equal to 15. K is equal to 15. We must find the value of k first. Then once we find the value of k, then we can now substitute it in that general one. So then the formula that will connect x and y will now be x is equal to 15 over the square root of y. Okay. Then the next question is now calculate y when x is equal to negative 2. Calculate y when x is equal to negative 2 is a matter of substituting. We can now substitute the value of x and y. So then when we have now x is equal to 15 over the square root of y, now you substitute. When we find y, when x is equal to negative 2, where there is x, we put negative 2 here, is equal to 15 over the square root of y. Then this what make 1. Then you can cross multiply. I hope we know how to work with fractions on both sides. Then you can, the way we did here, then we find out the value of y. So then it's just a matter of knowing whether it's inverse, whether it's direct, and you should know whether it's a square, it's a square root, cube or cube root. Those keywords you should know how to work with them as well. Then another part in this chapter is algebra. We have simplifying expressions, adding, subtracting, dividing, and multiplying. You should know how to work with linear equations, with brackets, with fractions, simultaneous equations, how to make the subject of the formula, then how to work with the indices, and we have reversed indices as well. We have polynomials, finding the quotient and remainder especially, and linear inequalities. These are not only on so then read and study every part under algebra. Then we have logs and sequences. We have laws of logarithms, and we have to use these logs to simplify these simple logarithms. And then we have to use logarithms to solve equations as well. And you should know when to use logarithms and when to use the laws of indices. Okay, and then under this one we're also having the nth term, and we're having arithmetic and geometric progressions as well. When it comes to the sequences, I can ask any type of these sequences in the examination, so then go through and every branch that is rooted from those chapters. Then we have graphs interpretation, graph interpretations, bar graph, charts, line graphs, and so on. And then we have to know how to work with Cartesian plane. Whenever a Cartesian plane is involved, you should know how to plot a point. You have to name a second point. You have to know how to draw those lines, straight line graphs. The graph of y is equal to mx plus c. You should know how to draw the curved graphs, and whenever those things are involved, we have to know how to work out the y-intercept, the gradients, as well as to formulate the formulas of the straight line graphs. If you are given the y-intercept and the gradients, how can we form up an equation? Then in conclusion on this, practice makes perfect, my dear students. So when practice makes perfect, make sure that when you are studying, you have your assignments. If maybe algebra, we have you have addition and subtracting, maybe expressions. Go further and know that you know how to add. You have to multiply and divide as well, and every other things there. Consider revising questions that usually carry many marks. Example, the number systems. They are quite simple, that is, it carry a lot of marks, numbers. Simple and compound interest, speed, distance and time, algebra, logarithms, solving equations. So then we know, even in your assignments, there are parts that you know that this thing is having a lot of marks. So then if you don't lose those marks. Know all the steps, the rules and the formulas, and then read the instruction very carefully and make sure that your answers are complete. Make sure that it's simplified, and I wish all the best in your study. Thank you very much.